My name is Nathalie Trenaman. I'm the Routing Security Program Manager for RIPE NCC. And today I would like to share with you some current developments in routing security. But we will start simple and easy, because not every one of you is a technical person. So we start with some basic stuff to get everybody on the same page before we dig into the deeper technical stuff of public key infrastructure, etc. So you heard in Axel's presentation earlier this morning a bit on who we are and what we do. One of the key things that we do is to give out IP addresses and AS numbers, of course. Why this is so important is because we have to ensure the uniqueness of those IP addresses, right? So we have to make sure that we only give out one block of addresses to one entity one time. And that is also important for the routing aspect of things. You cannot route in BGP, well you can, you should not route in BGP two prefixes from two different organizations at the same time. It does not work too well. So we have to ensure the unique holdership, and we provide a way for operators to document that holdership in what we have the RIPE database. So you can look up who is the legitimate holder of a block of addresses. Also important in routing. Also, we operate, as part of the RIPE database, the Internet Routing Registry. And that's a subset of the RIPE database where you have your root objects and your AS numbers and your block of addresses. Why is routing so important for RIPE NCC? Well, this story goes way back to the time where, in 1994, BGP, the routing protocol for the Internet, was also in that same year standardized. So around 1994, two things had to come together. First of all, the standardization of BGP, and the second, a place where you would document what you do in BGP. So in 1994, the RIPE community was the first community in the world, actually, that sat together and wrote a document, RIPE 181, it's still there in the archives, that described a way to publish these objects in the RIPE database for the Internet Routing Registry. And they described a language to do that, and your language was called RPSL, Routing Policy Specification Language. You can forget that immediately. But that later was adopted by all the other Internet routing registries in the world. So our community was already in 1994 quite active with thinking about routing security and documenting routing security. As RIPE and RIPE NCC, we co-developed the standards for the Internet Routing Registry, the database part, and later on also for RPKI. We have a very active community, very aware community of routing security, which I'll show you later on in some numbers as well. I will explain RPKI later, but one of the elements in RPKI is that we work with trust anchors. With public key, RPKI, public key infrastructure, you work with certificates, digital certificates. And we've got 5 of these trust anchors, these root certificates. And one is for RIPE NCC, and the other ones are for the other RARs, Regional Internet Registry. So you might have heard of ERIN and LACNIC and APNIC and EFRINIC. They each hold one of those RPKI trust anchors that we use to certify resources, IP addresses, for our members. We also have a tool, a validator tool. I'll explain that later on why that is useful. But we were the first RAR, as RIPE NCC, to develop a tool to do RPKI for the A to Z, for the whole way, for the whole miles, basically, to do origin validation. Now, I'm delving into technical stuff already a bit, so let's take it one step back, for those who are not that technical, and see a bit how that routing on the Internet works a little bit. Let's say you've got two parties. Party A has a block of IPv4 addresses and Party B has a block. And they want to exchange traffic with each other. So they have to tell each other which IP addresses they have so that they can announce and accept traffic for that. So Company B says, I have this block of IP addresses, and company A puts that in the routing table. So they know where to find company B, and the other way around. Simplified, of course, but this is more or less how it works. Now, in the old days, when you all knew each other, life was easy. You would know that this company B has a guy that you met at a conference, and you knew that his network was trustworthy and that he was a competent network engineer, and he knew you, and you had each other's email addresses. So that was all lovely and fine. But as the internet grew, you don't always know each other anymore. So how does then exactly you know whose prefixes to accept and who's not, and when they are a legitimate holder of a prefix or not? You can look that information up in the RIPE database, the Internet Routing Registry, because that is a trusted source of data. That is basically how it works today. A lot of providers, a lot of operators, a lot of internet exchange points build filters based on the information in the RIPE database. And that's all lovely, and that all works to a certain extent, until it doesn't. I'm going to explain a little bit what can go wrong there. But first, keep in mind that BGP is a very old protocol. It's from 1994. Security was not built in from the beginning. It's not a very forgiving protocol. If you make a typo, things can go bad pretty quick. Accidents happen. Now, for those of you who operate BGP in the room, who of you operates BGP? Who has enabled password on their routers? Okay, cool. Okay, now keep your hands up for a second. Yeah. Who of you, and you can put your hand down, keep your hand up. Yeah, keep your hand up if you never, ever made a mistake in BGP. Have a look around the room. Yeah. A mistake is easily made, and rest assured, it happens to all of us. Back in the old days, I was a network engineer, and I leaked a full table once. It only happens once, generally. And that is because these, on the keyboard, the 2 and 3 are pretty close, or, and that's a little bit worse, you start announcing the wrong prefix because you made a typo in the prefix, or you put a filter in a wrong place. Anyway, most of the times, by far, these are accidents. Sometimes they're not. And it's not really always easy to tell when it's an accident and when it's malicious. Who knows? Now here's a little story of what happened last year, which was quite bad. And we saw it happening on the 24th of April. So that's basically a week from now, exactly a year ago. On the 24th of April, in the middle of the night, a small internet provider in Ohio, in the US, starts to announce 1,300 IP addresses to their upstream provider that were not theirs. They were not theirs, but they did belong to Amazon's DNS service. That was strange. Their upstream provider propagated those 1,300 IP addresses because no checks at that time. Now, one of the customers using Amazon's DNS services was affected by this rerouting was a website called myetherwallet.com. Myetherwallet.com is a website where you can do basically your online banking for cryptocurrency, Ethereum. Now, if you went to that website, after that BGP hijack of those 1,300 IP addresses, and you had an account at myetherwallet.com, and you type myetherwallet.com, you get a pop-up saying this is not a trusted website. What do you think users do when they see a pop-up saying this is not a trusted website? Click along, yes, okay, whatever, go away, right? They do that. So what then, basically what they encountered was an unassigned SSL certificate. Anyway, they clicked it away, they still logged in with their login credentials, basically on a falsified website. with their login credentials. With that, DNS and BGP hijacked, because now it suddenly was both. The crooks, the criminals, which were not necessarily the guys that started to announce those 1,300 addresses, who knows? Crooks, the criminals, stole in 2 hours $150,000 of people who logged in with their accounts. Basically, their accounts were stolen. Just to give you an idea that hijacks nowadays also become lucrative. It's not only political anymore, it is also about money, unfair competition, etc. So incidents are common. Like I said, the vast majority is typos, mistakes. How many incidents are we talking about? Last year only it was a bit more than 12,500 incidents. 4.4% of all the ASNs in the world were affected. So it could very well be that one of you in the room was affected by somebody else starting to announce your space, or a more specific of your space. I got this data from bgpstream.com. They also have a nice Twitter feed where they give you updates on which prefixes seem hijacked. But anyway, the numbers are high. And we see this number growing, or at least we can't tell really if it's malicious or not, but we see the numbers of incidents growing. So what do you have nowadays to build on to prevent that stuff, basically? You can set up filters and basically only propagate what you know. So basically your customers, just set strict filters on your customers. You know the prefixes of your customers. But what you accept, you don't always have control about. So people use the Internet Routing Registry as a source of data for, for making those routing decisions. Now, if there were just 5, for the 5 regional Internet registries, that would be doable. But there are around 30 different routing registries. You've got commercial ones, you've got the RIPE database, you've got some others from regional Internet registries. But for example, ERIN does not have their own Internet routing registry. So the people in the US basically rely on another tool called RADB, Routing Assets Database. It's a commercial database, and you just have to pay them $500 every year, and you can put in there whatever you want. Anything? Anything. So that means you can basically put in the block of your competitor with your AS number in RADB, as long as you pay them $500. So what does that say about the trustworthiness of that information? And I'm saying this, but RIPE NCC is not completely free of guilt there as well. Because for years we allowed out-of-region address space, so address space that was not given out by RIPE NCC, to put in the RIPE Internet Routing Registry with a fake maintainer, with a well-known maintainer and a password. So even in the RIPE IRR, you could put anything. But the community said that's a really bad idea. We should stop that. So on September 4th last year, we closed that loophole. So now you can only create RIPE objects, routing objects, in the RIPE database. Because we have the way of verifying, because we have the maintainer, so we know who you are. So what does that say about the accuracy of the RIPE Internet Routing Registry? There's a map here, and what we did, we made a comparison with what we see in BGP, the announcements that we see in BGP, versus what we have in the RIPE IRR. And as you can see, inside our region, it's pretty good. It's because of the maintainer. But as soon as you look outside our region, there's a lot of mismatches between what we see in BGP and what is in the RIPE IRR. So how can you make trusted routing decisions or filtering decisions based on that? This is RIPE IRR. Let's have a look at RADB. This does not look better. Basically, this is what you have today to make your routing decisions on. And that data is not pretty. It looks decent for the US and for Canada mostly, but not at all for Europe. And who says that what is in the RIPE IRR is exactly the same as in RADB. There could be differences there as well. Or stale data, outdated information. You tell me, I have no idea. So it gets messy. Over years it gets worse actually. So this is why the community again came together in 2004-05 and said, okay, this IRR we can't really trust, we have to do something. So they came up with another way. Basically it's kind of sort of similar as the Internet Routing Registry, but now it's called Resource Public Key Infrastructure. And a lot of people mistake RPKI, they think it's about routing public key infrastructure. No, it's about the resources. Because it ties the IP addresses and the ASNs to digital certificates, to public keys, to private keys. And it follows the hierarchy of the registry. So like I said earlier, there are 5 of these trust anchors, 1 for every RAR. Because we should know who the legitimate holder is of space. Now, if you have those digital certificates that we have the root, you can also get a digital certificate. And that's quite easy. You just go to the LAR portal, you say, I want a digital certificate claiming I'm the legitimate holder of this space. Now, that certificate in itself are just a set of keys, doesn't say much. What you can do with that certificate is create authorized statements where you basically say, I'm the rightful holder of this prefix, and it should only be originated on the internet coming from this AS number. Signed, digital certificate, signed, the rightful holder of this prefix. And if you do that, it becomes more trustworthy. So RPKI has been in operation since 2008, and it didn't take off immediately. A little bit like IPv6 in the old days. Doesn't happen much. It is completely opt-in. It's important to realize that you decide if you want to create those statements. We call them ROAs. But if you have this whole pile of ROAs, this whole list of statements from everybody, what you could do is have that whole list of statements, all these ROAs, in a repository, inject them in your router and say, okay, if I see a BGP announcement and there is a ROA for it, and it's different information, then there is probably something wrong, and I will drop that BGP announcement. That process is called route origin validation. So the validation part. You have the list of ROAs, you have BGP, and then what do you do with it? It's important that the creation of those ROAs is really simple, because I know that the RIPE database to create objects is not always that simple. Creating the ROAs is a lot easier. You can do that in the LAR portal. It's quite straightforward. We give you examples, everything. So this is again a little bit a recap of how that chain of trust works. So the orange one, the all resources, that's RIPE NCC, that's the root certificate. And with that root certificate, we can generate certificates for our members. But you have to do that, you have to tick that box in the LAR portal, generate that certificate. And once you have generated that certificate, you can create, with your signature, those ROAs. Quite straightforward. But like I said, the true value of RPKI lies in origin, route origin validation. So you have those 5, what we call repositories, piles of ROAs, certificates, public keys. And you can basically load them into a tool, a software tool, called the validator. Now, RIPE NCC has one, Cloudflare has one, OpenBSD is almost ready, they have one, and LNet Labs has a validator called the Routinator. So there are parties out there that provide that software for free. They all do the same. They inject all those repositories in the validator, and the outcome basically gets passed to the router. What the validator does is nothing yet with BGP. The validator just checks if those ROAs, when they were created, have a valid digital certificate. So it does the key matching. The output of that key matching is what we call, that green arrow there, is called what we call the validated cache. The whole list of all those 5 repositories checked if the certificates were valid. Then that information, those ROAs, get fed into the router, and the router checks against the BGP announcements with some simple commands. Now, Cisco does that, Juniper does that, Arista is almost there, Bird does it. And that allows you to make better routing decisions. Now, okay, all nice and lovely, but how are we now doing with that RPKI stuff? Well, it's not bad, actually, especially in our region, and my slide is already outdated since last week. Because last week we had 7,100 certificates, basically members that clicked that tick box in the LR portal. Now already, a week later, we've got more than 7,500. So 400 were generated in a week. And that's why you see that spike, that yellow spike from RIPE NCC going up like this. It is a hot topic, and it's quite easy to set up. Now the other regions are a bit smaller, and that has mostly to do because, not that they don't like RPKI, because their member numbers are a lot lower than in our region. So keep that in mind. So Evrinic, for example, has not nearly as many members as we do. We have now more than 20,000. Okay, so that's all lovely, everybody's getting a certificates, but how many are creating those ROAs? Well, in our region, we're doing actually pretty good. We're creating ROAs, and also you see that in LACNIC, Latin America, you also see quite a lot of ROAs. The reason why is because they don't have an internet routing registry. They only have RPKI. So they're creating those ROAs. And then you see, maybe not because it's too far away and it's a bit faded, but this region, you guys are not very active with IPv6, but I have to tell you, with RPKI, you're doing amazing work. You're going really fast. For example, Bosnia and Herzegovina, 62% of all IPv4 addresses is covered by a ROA. And not only that, it matches 100% with what we see in BGP. Keep it up. Well done. You're leading the region in routing security, and I think that's quite an achievement already. So I hope, maybe after today, that you at least create those ROAs in the LR portal. And if you need help with that, talk to Stefania or Valentino at the service desk, or to me. We're more than happy to help you sort out those ROAs in the LR portal. Making a statement with what we see in BGP, if that should be the reality. We also see Serbia, 57%. Numbers here are quite high. Last week I was in Russia, numbers were quite a bit lower there. Okay, that's all lovely. So everybody is creating ROAs, everybody's getting those certificates. It looks quite accurate, but that's in our region. How is that going for the rest? If you look at this, this is the data of the people that create ROAs match in if what that is matching with BGP. Overall, it's 99.9%, and that's a lot better than the RIPE database and the RADB. So this allows you to make more trusted routing decisions. Quite a number of organizations are doing that at the moment. So to get started, create your ROAs, you're on the right way. It would be really cool to be leading in the whole region, the whole RIPE region, and get those numbers up, because you're quite far already. If you create those ROAs, there is one little tricky thing, one little tricky attribute, and it's called the max length. What we mean with max length, that's basically what are you announcing. So if you have creating a ROA for /21 or /22,000 IPv4 addresses, but in reality, you not only announce that /22 as one block, but also more specific /24s, you can set that max length to /24. So you create the ROA for /22, that's the total block, But if you plan to deaggregate, you can set that deaggregation value in the max length attribute. If we see people that make mistakes in ROAS, we often see that they leave the max length empty while they announce more specifics. If you leave the max length empty, that means we don't allow more specifics. So if you leave it empty, it means literally only that block. Something to think about when you create the ROAS. Download and run a validator. Like I said, we have one, Cloudflare has one, and LNet Labs has one. But before you start dropping packets, you might first want to check what you're about to drop. And at the moment, from the whole global routing table of close to 800,000 IPv4 routes, around 1,100 are completely unreachable if you start dropping invalids. That is because you don't do anything with the unknown stuff. If there's no ROA, just let it go. If there is a valid ROA, let it go. But only if there's something different in BGP and somebody created a ROA, it might as well be a typo from somebody or a hijack. Anyway, you can drop it. So that's 1,100 routes that you're losing. But you can monitor that, and I recommend you set up monitoring if you start playing with this, so that you see exactly which routes you're throwing overboard. And then you want to know, of course, okay, let's say I'm going to drop those invalid announcements. What breaks? Well, you're not the first to try that. Rest assured, quite a lot of ISPs are now starting to do that. And also quite some internet exchange points now start doing that. One of the comments that one of the ISPs said, not all vendors have full RPKI support, so maybe you can't even do origin validation or dropping invalids. So have a look at the current bugs, have a look at the documentation of the vendor. AT&T, very large ISP in the US, they just switched it on and thought, let's see what happens. And in their presentation, it had two big words on a slide. What happened? Mostly nothing. So that was good news. In the Netherlands, they received 5 customer calls in 6 months. Not too many. Basically, customer calls and says, hey, I can't reach this network in Japan. And you can look up in the validator, okay, that network in Japan has this prefix. Aha, I see there an invalid BGP announcement. Let me send an email to those guys and tell them that they have to fix their ROA. People that created that ROA know, yes, I created the ROA. Oh, okay, apparently I made a mistake in the max length attribute, probably. Let me fix that. That all was resolved within between 4 days and 2 weeks. Also, one of the comments they got was, if you explain that to a customer that it's not your network that's broken, but somebody else, their network is not secure, and that's why you're protecting them from it, customers tend to sometimes appreciate that. And say, okay, so I have a provider that cares about routing security. Nice, especially in the light, for example, with that money thing I just told you, that you're not propagating hijacks. One provider said, okay, there are many invalids, okay, 1,100, but what's the amount of traffic that I'm actually dropping? Because that's what we're talking about. If one of those 1,100 would be Google, nobody would drop invalids. But that was not the case. They said very little traffic was impacted. So that's all the good news. So my takeaway messages for you are, is routing security on your agenda? Create your ROAS. Let me know if I can help you with that. And have that discussion maybe with your upstream provider. Because with RPKI, it's not a solution for everything. It's not magic. But at least you can protect your door. And if you talk to your upstream, maybe your upstream's door. That's it. Let me know if you have any questions. Thank you.
Hi, my name is Kemal Shankta, in front of a company called 1000 Eyes. I know that RIPE NCC had the event in Zagreb just recently. It was more advertised as a deployathon. So I was interested in how that went and what lays behind the recent, quite hard push for that. I suspect that it has to do something with the most recent prefix hijack that Google experienced. So please let us know. Enlighten us.
Get to the question in our training courses all the time, asking, okay, this RPKI is lovely. It's lovely that RIPE NCC says you should do it, but I would also like to talk to other operators who already did it. I would like to talk to the software guys that basically built the validator. I want them to show me how to do that. They wanted to hear from, and basically play with it in a test lab. So we got all those questions all the time. And at one point we said, okay, we hear you loud and clear. Let's organize, not a hackathon, let's organize an RPKI deployathon. So we thought maybe 10 people will show up. So we invited all the validator guys, so from Cloudflare, from RIPE NCC, from NLnet Labs, to come over. We asked two ISPs to come, who are dropping invalids, to come over, and basically, and a guy with a test lab that we could use, and get all the knowledge in the room, all the RPKI knowledge in the room. And we were expecting maybe 15 people would show up or register for this. No, we got 60 people who wanted to register in a week and a half. We're like, okay, people want this. So we had 2 days, and we had different teams, and you could hop teams, so you could, with the registration team, set up your ROAS, and then set up the test lab, and install a validator of your liking. And then a lot of people created their ROAS. We saw it going up in all the stats. Looked good. We saw people actually at the end of the 2 days dropping invalids on one of the routers and monitoring it very closely to see what would happen. So there was demand for it, a lot actually. So much that we now get all the NOGs, operator groups, coming to us and say, hey, can you help us host it in our country? Because we would like to have that knowledge come in and boost routing security. So basically, it's not really completely led by the RIPE NCC. As we do, we facilitate. That's important for us. Like I said earlier, routing security is an important topic for us. So we are more than happy to contribute and to facilitate and do that. Does that answer your question a little bit? Yeah? Okay, thanks.
Yeah.
Yes.
Jan George. Basically, I have 2 questions. One in another. So, how to deal with invalids? So you can install it with lower local preference, or you can just drop it or reject it. What, or do nothing.
Yeah.
But so, what do you see as a trend? Is does people fear of rejecting routes, or do they more install it with a lower preference, or?
We see some people begin with lowering the preference and then monitor, basically, how many of those routes get the local preference, what exactly happens, the behavior. What we also see is that after a few weeks, they are confident to flip the switch. Also because they hear the stories and see the other presentations online in the archives from operators and IXPs that did flip the switch and told them mostly nothing happened. Except we lost a few routes. So those who tend to be more careful start with local pref, but then later still feel confident enough to drop.
So that's basically the best advice. Start with lower local pref, monitor, and then decide.
Start monitoring first, yeah. Yes. Yeah. Start testing and monitor before you flip that switch, yes.
Okay, thank you very much.
Yeah.
Hi, I'm Sergey, Internet Citizen. Actually, I have 2 questions. First is, do you have any numbers or estimates regarding validation in the worldwide scale?
Yeah, that's tricky. People want to know from us how many operators do origin validation. And for us as RIPE NCC, we can monitor a lot of things, but not what people do in the network, if they drop or not. It's hard to tell. I know Jeff Houston at Potteroo.net is doing some research on that. I also know that those numbers are not always 100% correct. So that's a really tough one to measure. But if you have any thoughts on how to measure it, any of you in the room, let me know. But
I see. Thank you. And second question. I heard the story that validation of the current routing table with 700 plus thousand prefixes will take a lot of time, like days. Is this true?
We had a while where only our validator took quite some time to load all the repositories. And this was the problem for a few weeks. We last week put down a new release, and I'm now working with the comms team to make the announcement. But the latest release, 4.407, is the one that loads now within 10 minutes. It's still a lot of data.
It's just for seven something thousand prefixes, right?
Sorry?
Is this just for the amount of prefixes of ROAS?
Yeah, but there are now more than 50,000 ROAS.
15,000?
Yeah.
How this is possible?
50,000 ROAS?
Yeah, at your slide there was like a, I don't know. Can you slide back to this?
This is digital certificates. So this is per member, but a member can have multiple prefixes, and they can create multiple ROAS. Yeah.
I see.
So in total, this is the amount of digital certificates, so LAR certificates, as you will. And every LAR can create multiple ROAS if they have multiple prefixes. And that number in total is now a bit over 50,000. Yeah.
I see. Okay, thank you.
You're welcome.
Ulf from B6.
Hey, Ulf.
Hey, Nathalie. You got route beacons going on.
Yeah.
And you got Atlas probes all over the world.
Yes.
Why can't you just have a route beacon with an invalid ROA?
We do.
And then check if...
and how far it propagates.
Yeah.
Yeah, we do. But we don't know really if they drop it because they do origin validation or they drop it for another reason.
Well, yeah, but you still can do a correlation. And if you have a probe, or if you have a couple probes in the same AS number, and all of their probes are not reaching it, then you can conclude that the route is dropped.
Yeah, to some extent, yes.
Yeah.
Yeah.
Yeah. So it's a correlation thing.
Yeah.
Hello, David Huberman from ICANN. I was actually going to get up and ask something very similar that Sergey did, but I have one useful data point at least. An academic study out of the University of Pennsylvania Law School, just at the end of 2018, somehow, and I don't know how, conducted a survey and found that 72 ASs worldwide were validating route origins.
Yeah, that number is also what I hear. That was end of 2018. We're going now towards the 150, but I can't really tell because I didn't do that research, and yeah, so definitely more than 72, probably around 150, but thank you for the addition. Very appreciated. Yeah, thank you.